All right, well, welcome to the 7.3 climax of I think what is one of the coolest parts of pre-calculus. This is a really, really cool thing, and it's super crazy powerful. And what I think one of the coolest things about it is that you already know pretty much how to do this. I just got to show you the few steps to get you there. 90% of this is what I'm going to talk about is things that you've already done and you've done pretty well so far. We're just going to integrate it. We're going to make a few connections and integrate a few ideas, and then I think everything after that will start to lock into place, and you'll be able to do some really, really powerful things. All right, let's get into it. What we're going to talk about right here is how to solve multivariable linear systems. Think about, for example, systems of equations you did back in algebra. So let's say you had 5x minus 4y equals negative 12, and x minus 4y equals negative 4. We wanted to solve these linear equations. There's two different ways you could do it. As you may remember from algebra, there's substitution and there's elimination. Substitution says something pretty simple. It says, well, let's just solve for one of the variables, plug it in, and solve for the other variable. So I would say, for example, I could solve for the second equation and say that x equals negative 4 plus 4y. And I could plug that into the first equation. I could say 5 times, let's see, negative 4 plus 4y, and then we'd say that's minus 4y equals negative 12, and then you just solve for y, and you'd have y. After you solve for y, you'd plug that back in, and you plug that back into the equation, you get x. You may also remember elimination. Elimination says, well, let's just add or subtract equations from each other so we can get something new. This thing is also valid. Because here's the thing: if I have, say, x plus if I say x plus 2 equals 7, I could subtract 2 from both sides, subtract 2, and because negative 2 equals negative 2, I can subtract the same thing from both sides, and I'll get another new equation. And that's something else that's true. X equals 5, and that's essentially what elimination is. It's saying, well, the stuff on the left side of the equation is the exact same. This stuff on the left side is the exact same as the stuff on the right side of the equation. These are both the same thing. So if I am subtracting both sides of the equation, if I'm subtracting both sides of the equation from another equation, I'm subtracting something equal. That sounds confusing. If I was to say, for example, 5x minus 4y equals negative 12, I could subtract the green equation from both sides. I'm going to subtract green minus green minus green. But what's the green equation? Well, on one side, it's negative x minus 4y. On the other side, it's negative 4. I can choose whichever one I want to subtract. I can subtract, on the left side, I can subtract x minus 4y, or I have the option of subtracting negative 4. I could do that. But I think, let's say I subtract x minus 4 on the left side, and I subtract, oops, that's the wrong color. I subtract a negative 4 on the right side. And I'm subtracting the same green equation from both sides. I'm subtracting just green. And so that gives me 5x minus 4y minus 5x minus 4y minus x minus 4y, and which we could just replace that as, that'd be minus x plus 4y, and that equals, let's see, negative 12 minus a negative 4, or negative 12 plus 4. Cool. And then we just solve from there. And so after doing that, then you can see, well, we've kind of lined things up pretty carefully. The things we subtracted are pretty convenient. So these negative 4y's cancel out, negative 4y plus 4y. And so you get 5x minus x, which gives you 4x, and you get 4x equals what is that, negative 8, and so x equals negative 2. And so you do that, you just plug x back in. You say, now I've got x equals negative 2. I plug that back into the original equation. I solve for y, and we're done. We've got both the answers for both equations. These are things we've kind of seen before. Let me just make this really clear, so I'm not just trying to jump too fast. This becomes negative 2 minus 4y equals, let's see, negative 4. I just plug this into the second equation. I could have plugged into the orange or the green equation, but I chose the green one, and that gives me let's see, that says negative 4y equals 2, negative 2, because I add 2 from both sides, and you divide both by negative 4, you get y equals 1/2. Okay, so this is a valid way of solving equations. You've seen this before, and this is a pretty straightforward process, I hope. It's because of this that we could say, for example, what we essentially did here, when we subtracted both equations from each other, we subtracted the 5x minus x, we subtracted negative 4y minus negative 4y, we take the negative 12 and subtracted 4. That's what we did. What we're going to see today is a way to extend this to more difficult problems, to use the same idea in a more difficult problem to solve a more difficult problem. And then we're going to find out a really easy way to do it with matrices. So let's start off with that. Let's say we have not just 2 variables, but 3 variables. How do we solve a problem like this? Well, there's a few tools we have at our disposal. I'm going to show you 2 ways of doing it. The first way I'm going to show you is just the normal method you might be that uses this rule of elimination a whole lot. And then I'm going to show you a second method after that with matrices. But let's look at the first method. This first method is called Gaussian elimination, and the reason why it's called Gaussian elimination is because it's made by this really super guy, a mathematician called Gauss. And anyway, he had a lot of really smart things to say. I don't have too much time to get into that, and I think you'd rather not me get into that because that could go on for a while. But let's jump into what Gauss actually said about Gaussian elimination. Well, there's 3 rules we can use in order to solve a problem like this. There's 3 tools that we have that people generally accept, and these are things, again, they should be pretty obvious, I would think. Let's rewrite the equation down. We've got 2x minus 4y plus z equals 10. Then I'll choose green for the second one. Let's say x plus 2y minus z equals 1. And let's do orange for the last one. Negative x minus 3y plus 2z equals 0. Okay, so there's 3 things we can do that you want to make sure you keep in mind as you solve these kinds of problems. The first thing you can do is you can switch equations. And this is almost a dead simple concept, but this is something that I want you to make sure you're aware of. So for example, if I take this, I'll copy it. We'll copy it, and I'm going to paste it back in so we can kind of see the example of the first one. Let's see, I'm going to paste. There we go. Okay, here's what we can do. I can take this green equation. I can take the green equation. Just see if I can select that. Oh, I didn't select the whole thing. I want to select the whole green equation. One note, please. Thank you. And I'll move that up. And then I'll take these 2 equations, move it down. In essence, I can switch the purple and the green equation. That's what I've done here. I've taken the purple equation, I've brought it down, took the green equation, moved it up, and that's a valid thing you can do. It's not really a rule per se of like an operation, it's just more of like, remember, you can do this. This is helpful. It seems dead simple, but it'll become very clear as to why I'm saying this soon when we get into the actual matrices. So that's rule number 1. Rule number 2 is that you can multiply both sides of the equation by a number. You can multiply both sides of an equation by a number. This similar to how if things didn't line up so easily with this elimination method, you know, back in algebra, you might learn that if this was like a negative 8y on top and then a negative 4y on the bottom, you can multiply both sides of the equation by 2. You can do 2 times that, all this times 2. You can multiply both sides of the equation by 2, and you'd still get a true statement. Or not, you wouldn't multiply the top one, just multiply just the bottom equation by 2. So that you get that minus 8y, you can line them up and then subtract. Same thing here. Exact same thing here. So if we can take any equation, let's say, for example, because we will want to do this soon, we're going to want to line up the orange x with the purple 2x. Well, if I want to do that, I've got to multiply both sides of the equation by 2, at least the orange equation. So for the second equation, let me just give it some more space here. make sure we have enough room. Okay. I'm going to go ahead and copy this again and paste it down. Copy and paste and paste. Hopefully, paste please. Thank you. Okay, I can take both sides of the equation. This is rule number 2. No, I don't want to do that. I don't want to change the colors because I like the colors. Please don't change the colors on me. Thank God. There we go. And I can multiply both sides of the equation, this equation, by 2. 2 times this, 2 times that. I can do that. That's essentially all it's saying. And so that'll give me negative 2x minus 6y plus 4z equals 0 times 2 is 0. And so we can do that, and then we can cross out this side and say, okay, well now this is the new orange equation. That's a totally valid move. Okay, the last thing we can do is you can add 2 equations together, because that's literally what elimination is. And here's what we're going to do with this one. I'm going to take now they've lined this up, I can add the purple equation to the orange equation, because I've got a plus 2x on top and a minus 2x on bottom. I can add these 2 equations together, and if I did so, it would eliminate the plus 2x and the minus 2x. Okay, here's what this means. If I were to copy this one more time, I can copy it. Okay, hopefully I can actually select. Oh, I'm in text mode, not select mode. Okay, I'm going to copy this and then go to text mode and paste. Okay, so rule number 3 says that what we can do. Oh, I made a mistake again. Let's paste it. Select out. There we go. There we go. Now I'm learning the system. Okay, so rule 3 says we can take this middle, the purple equation and orange equation, and we can add those 2 equations together. So I will add. Let's say I'll add these 2 together, and that can be our new orange equation. So let's say I'll add the 2x plus the minus 2x. That gives us 0. Negative 4y plus negative 6y is negative 12. Not negative 12, negative 10y. Negative 10y. And then z plus 4z is plus 5z. And then 10 plus 0 is 10. So that becomes our new orange equation. Okay, why did I want to do that? What was the purpose of that? Well, here's what we're trying to get to. We want to get to a place, we want to finally get to a place, and our goal is to get to a place where if we can get one variable in one of the equations, then we can solve for that variable. If we can eliminate enough to get to one variable, we can solve for that one variable. And then when we solve for that one variable, we can substitute that one variable into all the other equations and eliminate that variable in all the other equations. That sounds like a lot of words. Let's try to explain this in a cleaner way. I'm going to go ahead and select this below. So the way we use these different tools, let me just kind of let me copy this here. I'm going to give you a method to work with this. Now, if you understand these rules and they make sense to you and you know how to use them, well then, perfect. And for some of you, after I go through these rules, you're going to want to find faster and more efficient ways of doing these problems just because you feel like you can do it. Great, that's wonderful. And in fact, you can find faster and more efficient ways of doing these problems using those 3 rules that I just described. Now, but for some of you, you just might want to say, well, I just want to know the rules, I want to do the rules, I want to solve the problem, I want to solve the problem right every single time. So here's a surefire method to solve this problem every single time. And it starts off like this. Let's say I'm going to start off with an example of a different problem. Let's say we had a much larger problem. Let's say we had 3x plus 4y minus 7z plus 2a equals 7, and then 2x plus 4y minus 13z plus 1a equals 6, and then 3x minus 17y plus 24z plus 2a. These variables really don't matter so much, but I'm just trying to clean it up, make it pretty clear what I'm trying to get us to do. Minus 6y plus 8z plus 14a equals 8. You can see that my brain is not random at all. It just kind of goes in patterns. That's the way that all brains work. If you try to make up a bunch of random numbers, you're actually going to end up making a pattern usually. Something that's less random than what a computer can make. Even though what computers make isn't random either. But that's a different story. Okay, so here's what you want to do. You want to try to eliminate variable by variable. So first thing you want to do is you're going to take these two, line them up, and eliminate this bottom variable. So the first thing you want to do is eliminate the bottom variable. And after you eliminate the bottom variable, you now have an equation so that there's only 3 variables left. Okay, so then from here, you just want to try to eliminate more x's. So you want to eliminate, the next thing you want to try to eliminate is this variable. Oops, that's the eraser. You want to try to eliminate the variable right above it, the 3x. And you do that by lining up. You won't have, come on. You won't have that bottom variable up anymore, so you want to try to line up these two variables so they're the same number, and then eliminate this variable here, the 3x. And then just like that. And then after that, you'll want to eliminate the variable above it. You want to line up these two variables so they are the same number, and then eliminate the variable beneath it. And so these equations can be changing a whole lot while you do this. So you do that, and then after that, you want to eliminate. You want to move on to the next row and say, okay, I want to take these two variables and work with them, so that I end up eliminating one of those, or the bottom one of those. And then after this, you want to try to work with the bottom equation and try to delete this variable and find some way to eliminate that variable. And then after that, you want to line up these variables and try to find a way to eliminate this one, eliminate the second one. And you keep going, and you can kind of start to see a pattern here a little bit, but then you stop here. So you leave one variable up top of the first one, then you leave two variables up top of the second one, and the next one will leave a third variable up, which means we're just going to try to align these up so that we eliminate this variable. And then finally, we'll just do the last variable alone. And so you can see if we did enough elimination to get all those variables eliminated, what you would see is that you've got, on the very bottom row, you've got 14a or something. This would be a very different number now that you've done all these operations. You get something of a equals 8. So you can solve for a from here. Once you've solved for a, you can plug that answer for a up into the next equation, and then you can say 24z or whatever times z plus whatever times the answer for a, the solution for a, equals 4. From here, you can solve for z, and then after this gives you a equals something, so you can plug that a in. Then over here, you'll find, because you've already have a solved, you can solve for z, so you get z equals something. And then from there, now you've got z and a solved. So now you've got z and a solved. You can plug both of those into the next equation to solve for y. And then that'll give you the solution for y. And then after that, you'll put all three of those into the first equation, and that'll give you the solution for x. A lot of really heady stuff there. If that doesn't make sense, let me show you the example. And let's work this out practically. So we will do this. The first thing we've already done the first step in this problem just by walking through the examples. We've eliminated, working through the example, we've eliminated, what have we eliminated? We've eliminated that bottom left corner. So now that bottom left corner is a 0, and that's exactly what we want. So we're going to move that up, and now we're going to try to solve. We're going to try to eliminate that 2x. Try to do whatever we can to eliminate the 2x. And so to do that, we can say, well, if I want to align up this 2x with the x, I can multiply both sides of this equation by 1/2. 1/2 times and 1/2 times 1/2. Okay, and so then I'll get, and so if we do this, that gives us x. Let's see. Let me see if I can make it a little bit more space here. No, let's do it on the side. Actually, you know what? Let's do it. Let's make sure we have a little bit more space so that we are clear, and this becomes a little bit neater. Okay, so this becomes 1/2 times 2x becomes x, and then 1/2 times negative 4y is negative 2y, and then 1/2 times z would be 1/2 z, and plus 1/2 z equals 1/2 times 10 is 5. Okay. Now I've done that, we can oh, the equation is purple now. It should be orange. Okay. And now we can get rid of that first equation. Now, initially, like if you're doing this on paper, you'd want to keep all of your work. It'll get kind of messy, and that's okay. But you want to make sure you keep all your work because it's really easy to make a mistake, and it's extremely easy. Remember how in the last set you can make so many different mistakes just doing basic arithmetic. This is one of those things where you just bash your head so many times against the problem, your brain can get tired and it can make mistakes super easily. So it's okay to keep your work even if it gets a little bit messy, because you want to make sure that you aren't making that if you do make a mistake, you can backtrack and figure out what you did wrong, so you don't have to do it all over again. Okay, so now we've got this answer. So now that we've gotten this answer, we can subtract the top equation from the bottom equation to get a new purple equation. Okay, so this gives us our new equation. We'll get x plus 2y minus z equals 1. We'll get 0 minus 10y plus 5z equals 10. Okay, and then from here we will take 1/2 and multiply it through. Or we'll take this new equation and we'll subtract this x from that x. That gives us 0. That gives us 0. And then from there we will subtract the 2y plus 2y minus the negative 2y. So that gives us 4y. So that's plus 4y. And then we'll do, let's see, negative z minus 1/2 z. So that is let's see, it's negative z minus 1/2 z. Yeah, that's minus 1.5 z, or 3/2 z, equals 1 minus 5 is negative 4. Okay, that looks a little bit confusing. Let's make this 3/2 minus 3/2 z. Okay, great. So now we've gotten these two to turn into 0. These two turn into 0. Now we're going to go to the next one. We're going to go to the next row, the y's, and we're going to try to get the y, the bottom y, to equal 0. So negative 10y, we're going to make that turn into 0. So in order to change this up, we will need to divide both sides by a number so it equals that 4. Okay, so to make it the same, we will multiply by, I don't know, 4/10. Yeah, 4/10. And we will do that. So that gives us, let's see if I can make more space here. I'm going to go to text mode and move that down a bit. This does take a lot of space. I often underestimate how much space it'll take. Okay, so this does, let's see, we'll do negative 10y times 4/10. So we'll multiply both sides by 4 over 10, or which is 2/5. So 2/5 times this side and 2/5 times that side. 2/5 times both sides. So it gives us 0 minus, let's see, times 2 divided by 5 would be 4y, plus 5 times 2 would be 10 divided by 5 would be 2. So plus 2z equals, is that right? Yeah, that's right. Okay, I just want to be sure because it's again really easy to make a mistake here. So that gives us then 20 times 2 divided by 5, which should also be 4. Okay, great. So now we add these two equations together. We've got a, oh, did this incorrectly? No, I did this right. So now we can add the purple equation with the orange equation. This one is kind of inconsequential. Try to ignore that, but that's a little bit inconsequential. So now we'll add the two together. So that will give us, let's see, 0 plus 0 is 0, negative 4y plus 4y minus 4y is also 0, and negative 3/2 z plus 2z would be negative, let's see, negative 3/2, that's negative 1.5 plus 2 would be 1/2 z, plus 1/2 z equals 4. No. Negative 4 plus 4 would equal 0. Equals 0. And so that's good there. Then we can jump ahead from there. So we say 0 plus 0. Did I do that right? Okay, so negative 3 halves plus 2z, that is, yeah, negative 1, that's negative 1 1/2 plus 2z should be 1/2. Great. Okay, so we got 0 plus 0 plus 1/2 z equals 0. Now we're what's called row echelon form. In a sense, called row echelon. This is not really, we'll get to, it's actually called row echelon form when you look at it in a matrix. But for now, we can almost call this row echelon form. Let's rewrite it so that it's clear. I'm going to copy this and bring this down. Copy that and bring it down a bit. Okay. This goes down here. And then I'm going to copy this up here, these bits up here, all this up here. And then this goes down here. Okay. So this is the form we're looking for. We get this nice diagonal of zeros here. Oh man, did I change the color again? There we go. We get this nice diagonal of zeros here. That's kind of what we're looking for. It's this triangle form. This is actually called the triangular form because it creates a triangle this way. If you look this way, if you look that way without an eraser, if you look this way, it creates a triangle of sorts. So this is called triangular form because it creates those triangles anyway. So that's what's going on there. Okay, from here we can solve this though. We can solve for z because 0 plus 0 plus 1/2 z equals 0. We can solve that. We can solve for z here. You might be able to do this in your head. In this case, z equals, oh my, z equals 0. And then I can plug that into the equations above and solve the other equations. Now be aware, when you do this, you might end up with a different, if you do this using non-standard means, if you get to this form using another means than what I got to, then you might get different numbers on the left side and the right side. That's okay. It might be a bit different, but it'll still get you the same answer, assuming you did everything correctly. It's like in the sense that you followed rules and didn't like make a mathematical error or arithmetic error. So that'll work. So we can solve this here by solving for z, substitute z in for this purple equation. So we get, let's see, plus 4y minus 3 halves times 0 equals negative 4. So that gives us 4y equals negative 4. So 4y equals negative 4, or just y equals negative 1. Great, so y equals negative 1, z equals 0. Plug this into the first equation, we'll solve for x. So we've got x plus 2 times negative 1 plus, let's see, 0. Yeah, sorry, not plus 0, it's a minus 0, but it doesn't matter. That's a minus 0 equals 1. So we've got x plus, let's see, x minus 2 equals 1. So x minus 2 equals 1, and then x equals 3. So our final answer is x equals 3. Actually, let's use a different color. Let's say that our final answer is x equals 3, y equals negative 1, z equals 0. And that is our answer. And that's how we solve. Now we've figured out the variables that work with that equation. Great. It's a long and tedious process, and it takes a while, but it is doable. Now let me show you the exact same method through rows and matrices. I'm going to do the exact same things, but it might be a little bit faster if we use this kind of method. Okay, let's first review our rules, what we can do. If I want to turn this into a matrix, what's really convenient is I can just take each of the coefficients and make those numbers in the matrix, and then the answer will be another number in the matrix. Let me explain what I'm saying. I can write 2, negative 4, 1, 10 from our first row. The second row can be, let's see, the coefficient to the x is 1, then 2 for the coefficient of y, and then negative 1 and 1. And then we have our third row. We have negative 1, negative 3, 2, and 0. So this is our orange row. This is our green row, and this is our purple row. And then for our columns, we have x, y, z, and our coefficient, or not our coefficient, our constant, our number. So that's kind of the way we can set this up. We can set it up in those kinds of variables can be very convenient. So here's the things we can do. This is our new matrix. We'll just make this is our matrix now. And so with matrices, you can do a lot of really powerful things. Let's start off with the simple stuff. And this is the reason why I went through this almost really bone dead answer, not bone dead, but pretty simple stuff, simple rules. So we can switch two of the rows. So I can switch the green and purple. So I have 1, 2, -1, 1 on top, and then I can have 2, -4, 1, 10 in the next row, and then -1, -3, 2, and 0 beneath that. So I can do that. That's the rule number 1. Rule number 2, it says that I can multiply any row by a number. So in this instance, I can double orange. I can take the orange row, and I can multiply it by 2. So I'll copy the first two. 1, 2, -1, 1, and 2, -4, 1, 10, and finally, I want to multiply. I want to take 2 times this entire row. I can multiply it 2 times that entire row. So that gives me -2, then -6, and then 4 and 0. Cool. So a much faster method of doing the same thing. It's kind of like a shorthand in some ways. At first it's like a shorthand, then it becomes much more powerful. Let's talk about how it's shorthand first. Okay, so this is our new matrix now. We can subtract two equations from each other. So I can subtract the purple from the orange, because again, I want to start off by getting rid of that bottom, or start off by getting rid of that bottom left number. I want to turn that to 0, and I want to eliminate it. In order to do that, I'm gonna add the purple equation and the orange equation together. So I'm gonna add these two together. So we can add, that sort of thing, and that'll give us let's see, 1, 2, -1, 1, and then 2, 4, 4, 1, 10. Those are the same from before. And then when I add that to the orange becomes 0, -10, 5, and 10. Okay, we can continue this same pattern, using the same tools as before to solve it in the same way. Okay, I'm going to go ahead and copy this down because that took a second to write. Copy, and then over here, I'm going to write, oh yeah, that was an example. Let's go back over here where we're solving this problem. I know it's taking a few seconds for me to explain it, but I hope you bear with me because this is usually really confusing for students. And so if you're just bored here, that's excellent, which means you understand this and this makes a lot of sense. And so I'm really pleased by that, because normally if you don't get this down first, that can cause a lot of trouble for a lot of students. And so I'd rather you be bored right now than really confused. If you are bored, just skip forward. I don't care. Okay, so the next thing we want to do is we want to get rid of that. We want to get rid of this second one. Oops, I changed the colors again. The second thing we want to do is get rid of this 2. I want to turn that into 0. And so to do that, I've got to line it up so it equals 1. So I turn it into a 1. So I can divide it by 1/2. So let's erase that. I can not divide it by 1/2. I can multiply both sides by 1/2, or divide both sides by 2. I can divide both sides by 2, or I can divide this row by 2. So that gives me, let's see. I condensed it all in one row there. So it gives me 1. If I divide both sides by 2, let me just try to find the best way to write this so it's clear. This becomes, oh no, I just erased that. That's not helpful. So let's write it right beneath it. That's what I'll do. 1, 2, 1/2, and 5. And there's my first mistake of the lesson. Probably my last. When I copied it over incorrectly. This is supposed to be a -4 and a -4, which makes this a -2. All right. So when I copy this down, when I do this, I'm going to subtract both sides. I'm going to subtract the purple from the green. So this gives me 1, 2, -1, 1, and then we will subtract the purple from that, which gives us 0, and then 0, and then -2 minus -2 is a 4. Yeah, 2 minus a -2 would be 4, because that's 2 plus 2, and then 1 minus 1/2 would be 1/2. No, would be 3/2. That is -1 minus 1/2 is -3/2. Am I doing this right? No, I'm not doing this right, am I? Oh yeah, I'm doing this right. Because negative 3 halves, and then finally 1 minus 5 is negative 4. Okay. Oh my, I hope I didn't confuse you yet. So I chose a little less of a verbose option. I mean, in the sense that it takes up less space. I tried to condense a few steps into one, but because of that, I confused myself. There we go. So this is what we end up with, and that's the same thing as this rule down here. So I've eliminated this row. So I've eliminated the orange, the orange x and the purple x. I've made 2 zeros on the left side. Now I want to work on this negative 10 here. I want to make that. I want to get rid of that. So I've got to make that the same number as 4. And so in this instance, I can multiply it by negative 2/5. I can multiply by positive 2/5. It really doesn't matter. But I want to multiply this by 2/5. 2/5 times this row, and so that gives me. Let's just write down the whole thing so we're clear here. So don't make another mistake and I confuse you even more. So 1, 2, negative 1, and 1, and then 0, 4, negative 3 halves, and negative 4, and then 2/5 becomes 2/5 times 0 is 0, negative 4 times 2/5, or sorry, 4 times negative 2/5 times negative 10 is negative 4. Negative 4. And then 5 times 2/5 is 2. And then 10 times 2/5 is 4. There we go. This seems right. All right. And so now we can add these, the purple and the orange together to get rid of that orange section. So that gives us 1, 2, negative 1, negative 1. Then we get, let's see, that gives us, let me write it down. 1, 2, negative 1, 1. Then 0, 4, negative 3 halves, and negative 4. And then for orange, we have 0 plus 0 is 0. 4 plus negative 4 is 0. Negative 3 halves plus 2 is negative 1/2. It's negative 1/2. No, 1/2. It's 1/2. Oh my. That does not bode well for the rest of the lesson, because this is all just arithmetic. Negative 4 plus 4 is 0. Okay, so now we've got this, and this is officially what's called row echelon form. Row echelon form. Now from here, let's actually write that down. This is. Oh, did I get rid of everything? Oh man. Oh man. Oh yeah, here we go. So we've got, this is called row echelon form. And you see, we did the exact same steps and end up with the exact same place as this on the left. As this set of equations on the left. If you were to turn that into a matrix, you would get this matrix. Okay, a lot of stuff that just shows something. I hope that's not too complicated. Just it's easy to mess up. Okay, now from here we could solve it using this other method. We could solve using substitution, but there is another method that is perhaps a little bit more straightforward. That might make this even easier than that. We can solve this. The rest of this, we can solve this matrix by doing something called creating what's called reduced row echelon form. Okay, and you can find I'm going to do the same things on both of these equations, and you can see how I'm doing something that's completely justifiable on both equations, but gives us the answer, and maybe in one way is a more complicated way, and one way is hopefully a more simple way. Okay, let's go ahead and paste this down here. Here's how you find reduced row echelon form. All right, now solving with reduced row echelon form is pretty similar in many respects, except now instead of just doing the normal row echelon form, creating this triangle here, this triangular form as some call it, we're gonna create an inverted triangle the other way around. Reduced row echelon form makes a triangle with the opposite triangle to be 0. And there's a buffer of 1 in between each of them. Okay, there's one other thing. When we do this, this will become the centers will become 1. This will become 9, this will become 1, this will become 1. That's really confusing. Let's just work it out, and I think I'll show you how this actually makes a lot more sense than is almost hopefully intuitive. Let's start with the logic of what we would do to try to solve the normal equation, not the matrix. Well, we'd say we want to solve for z, right? So we take z, and we'd say I want to solve for that. So I'll multiply both sides by 2, so I can get rid of that 1/2. So I'd multiply this side by 2 and this side by 2. Forget the zeros for a second. The zeros don't really matter so much. I'm going to multiply both sides by 2. So I'll do the same thing with this matrix. I'll multiply this matrix by 2. And so what I get is, let's copy this down. Let's copy that down, because that just takes forever to write. And I hope this example doesn't become too overbearing. That way, I'm going to copy that. I'm going to paste this down here. I'm so glad I learned to copy and paste. And I don't understand why I do that, but that still happens where it jumps to the top sometimes. Okay, so we've got this, and then this will become, not orange. This will become 0, 0, and then z equals, let's see, 2 times 0 is 0. So you've got 1z equals 0. You can just get rid of these zeros if you wanted to and say z equals 0. Okay. And then on the other side of the equation, we would do row echelon. When we do the matrix form, we get 1, 2, negative 1, 1. We get 0, 4, negative 3 halves, and negative 4. And then we have, let's see, 2 times all of this, so it gives us 0, 0, 1, 0. Great. We've got a 1. The left sides are all zeros. The right side is 0. It doesn't matter what the right side is. We've got the 1 there. And so our goal is essentially to make all of these become 1s. And then make a triangle of zeros. From here, we say, okay, well, I know that z is 0 now. So from here, what I want to do is I want to eliminate the z above it. I want to get rid of that z and replace something else so I can help figure it out. So I guess if you want to think about it in row echelon, in a matrix form, what we would do is we would say, okay, I want to do another elimination. I'm going to take this z, and we're going to eliminate this negative 3 halves z. So I want to line them up so that I can eliminate them. If I want to line them up, I'm going to multiply this by 2/3. 2/3. So this by 2/3, and that lines up so I can do another elimination on this side. But it's kind of like an inverse elimination. So instead of eliminating a variable beneath, I'm going to eliminate a variable above. That's confusing words. I'll try not to use that again. Equals 1, and then z, we get 2/3 times all this becomes 0, and then 4/3 plus 4/3 y minus, let's see, 2/3 times negative 3 halves is that just, well, it's just 1, isn't it? Yeah, that's 1. That's what we wanted to. We want minus 1z equals negative 4/3. Great. So then we have this, and then z equals 0. Okay, and then we can eliminate that z. We can add both sides. We can add both sides of the equation to eliminate z. So we will do z. We'll do x plus 2y minus z equals 1, and then 0 plus 4/3 y, and then negative 1z plus z, that's just 0, plus 0 equals negative 4/3 plus 0 is just negative 4/3. At the bottom, we still have z equals 0. So I eliminated something and made up the purple equation instead of the orange equation. Excuse me. Okay, great. So I'm going to do the same thing on this other side. Fortunately, it'll take a little bit less time, hopefully. I'm going to multiply both sides by 2/3. I'm going to multiply this by, hopefully in a way that looks somewhat reasonable. 2/3 times all this. So we get 1, 2, negative 1, 1, and then 0, 4/3, and then negative 1, and then negative 4/3, and then 0, 0, 1, 0. Okay. Okay, and then we add them together, and so we add these together, so we get 1, 2, negative 1, 1, then we get 0, 4/3, and then 0, and then negative 4/3, and then the same 0, 0, 1, 0 at the bottom, 0, 0, 1, 0. Okay, now from here, we can say we got 4/3 y equals negative 4/3. We can pretty simply solve for y here. We can do a pretty easy solution for y. If I multiply both sides by 3/4, I will figure out what y is, because that'll eliminate both sides. So I'll multiply this side by 3/4, 3/4 times that, and then this times 3/4 times 3/4, and that gives us x plus 2y minus z equals 1, and then y, or say, we can get rid of those zeros. We can say just y equals negative 1, and then z equals 0. Z equals 0. Okay, great. And we can do the same thing on the right side. We will multiply both sides by 3/4, and we will get 1, 0, or sorry, 1, 2, negative 1, 1, and then 0, so yeah, 0, 1, 0, and then negative 1, and then 0, 0, 1, 0. So you can see, again, this is a lot like a shorthand way of doing it. And so because it's just such a shorthand, I'm going to go ahead and finish this problem with the shorthand. So I think you kind of get the idea of what we're doing here on both sides, hopefully. And that we just shouldn't make it that small. I was trying to scroll there. There we go. I'm going to move over to the right a bit and finish this up. So I'll go ahead and paste right here. No, I'd rather paste over here. Can I paste over here? There we go. Okay, so now I want to get rid of these. I want to get... I hope I'm not wasting your time. Okay, here we go. I want to get rid of these two variables. I want to get rid of these last two. And to do that, we're going to add both of the equations in. I'll start with the orange one. I can add, because this one, negative 1, is the same value as this one, I can add the two equations together, and I'll get a new equation. So I can kind of just say, I'll just say plus, I want to plus row 3 is what I'll do. And so it'll give me, let's see, it'll give me 1, 2, 0 plus 1, 0 plus 2 is 2, negative 1 plus 1 is 0, and then 0 plus 1 is 1. And then I'll get, let's make a partition here, 0, 1, 0, negative 1, and then 0, 0, 1, 0. Okay, so I want to eliminate that green 2. So what I'll do is I'll add the purple, but I'll add 2 times the purple. If I add 2 times the row 2, if I add 2 times row 2, I'll be able to, or no, if I don't add 2 times, I want to subtract 2 times from row 2. If I subtract 2 times of row 2, I'll be able to subtract enough to get rid of this 2, because they'll be the same value. Here's what I'm saying. So 2 times row 2, 2 times row 2 would be 0, and then 2, and then 0, and then negative 2. And so now I can subtract that. This is 2 times row 2. I can subtract that from green, and I'll get a true value. I'll get something else that works. So 1 minus 0 is 1. 2 minus 2 is 0. 0 minus 0 is 0. And then 1 minus negative 2 would be 3. Okay, so we've got 1, 0, 0, 3. Then we've got 0, 1, 0, negative 1 from before. And then 0, 0, 1, 0. Great. And so now this is what's called reduced row echelon form. You can tell it's a reduced row echelon form because it's got a triangle of zeros on the left, it's got a triangle of zeros on the right, and everything in the center is a stream of ones. This is called reduced row echelon form. Okay. Now, why is this helpful? Why would you ever want it in reduced row echelon form? Well, here's this actually is the answer. This is the solution to the problem. Remember how I said in the beginning, this is the x column, this is the y column. Let's use the right colors. Let's use red. This is the x column, this is the y column, this is the z column, this is the number column, the constant. And then this, we'd say for 1, it represents x. If you were to turn this back into an equation, you would have x equals 3, or 1x equals 3. We'd have 1y equals negative 1, and then we'd have 1z equals 0. So x equals 3, y equals -1, and z equals 0. And that's our answer. We found the solution by finding reduced row echelon form. Okay. So that's that form, and that's how to find reduced row echelon form. A quick note though, if you're ever trying to solve this and you ever find out that you end up, instead of getting like z equals 0 or something like that, you end up something like, what happens if you end up with like, instead of z equals 0, you got something like 0 equals 0. Well, if you ever end up with a 0 equals 0 at any time, just like in the other forms, with elimination from algebra, just like with elimination from algebra, if you ever end up with 0 equals 0, or 1 equals 1, or 7 equals 7, or 20 equals 20, at any point, you can immediately stop and say there are infinitely many solutions. You can just stop everything you're doing and say there's infinitely many solutions. If at any point as well, you ever end up with something like 0 equals 5, or 0 equals 1, or -2 equals 6, something that doesn't equal because they're not equal, you can immediately stop whatever you're doing and say there are no solutions. So just a quick caveat there. If you're ever working and get 0 equals 0, then infinite solutions. If you ever get like 0 equals 1, you get no solutions because 0 does not equal 1. Okay, so that's row echelon form, reduced row echelon form. I'll show you all how to do this more in the problems below. I'll just work more problems, so hopefully it'll make more sense. But now we're going to do the same thing, the same problem, but I'm going to use something called matrix math. This makes it even faster, or at least a ton faster. So this is the point where it's all like, well, you did all this stuff before, and you learned how to do this stuff, and you learn the mental stuff, but here's a way to kind of cheat your way forward and make it done really fast. If you know what you're doing. If you know the things from what we learned in the last lesson about how to do matrix algebra. So we know that. Let's take that same problem from the very beginning. Let's say this is our initial problem. Okay. Actually, let's take the matrix form of that problem. I'm going to copy that. Copy that, Roger. I'm going to paste this down all the way down here. Okay. So if I take this and paste it, okay, we have this equation, we have this matrix, and we can split this up into two separate matrices and kind of think about it this way. If I have one matrix that's 2, -4, 1, 1, 2, -1, and -1, -3, 2, we'll call this our constant matrix, or coefficient matrix. This is the matrix that comes up with all of the coefficients of all of the numbers. These are all our coefficients. So we often just use A. Oftentimes when you look at formulas, and at least the formulas you do in this lesson, most of the time when you see matrix A, they're talking about this section here. So that's one of them. And we're going to say, make another matrix called 10, 1, 0, that extra stuff, the numbers on the end. We'll call this matrix B. Okay. Now, if matrix A is a square matrix, which it usually always is, we can use matrix algebra in order to solve for this. We can actually figure out that matrix A times another matrix, we can call it matrix X. I think it's kind of confusing calling it matrix X, but we'll call it matrix X. This means we'll call matrix X, Y, and Z. And we'll say that equals matrix B. Matrix X times, or matrix A times matrix X equals matrix B. And this might seem like a really bit of a daunting idea. Like, well, what does that even mean? Well, if we were to actually multiply this through, 3 times, this is a 3 by 3 matrix, and this is a 3 by 1 matrix. If you were to multiply this through, if you can take a few seconds to try it on yourself, I encourage you to try it yourself. I think you'd find it, enjoy it. Well, I don't know. I think you'd be able to figure out exactly what I'm talking about, and it'll click pretty well. But if you multiply this through, you'll get 2x minus 4y plus 1z for the first one, and then 1x plus 2y minus 1z, and then negative 1x minus 3y plus 2z. That would be this matrix multiplied together. Okay. And it would all come together whatever those values are, we don't know what those values are, but if we were to know what those values are, we'd end up with a 3 by 1 matrix. We'd have a matrix. This is all one entry, this is the second entry, this is the third entry, and whatever those numbers are, whatever those solutions are, that'd be B. But we know what negative 2x minus 4y plus 1z is. That is 10. We know 1x plus 2y minus 1z is 1, and then negative 1 plus 3y plus 2z equals 0. How do we know that? Well, that's what the original equation tells us. The very, very, very beginning. The initial equation tells us those exact things. 2x minus 4y plus z equals 10, x plus 2y minus z equals 1, negative x plus 3y plus 2z equals 0, all of that. So that this is the exact same thing. And we can say, oh yeah, these things, this top bit, that equals 10, the middle bit equals 1, and the bottom bit equals 0. So in other words, all I'm trying to say here is this is a true statement. This logically follows. Matrix A times matrix X creates matrix B. If we knew what the variables were for matrix X. Now here's the question: how do we find the variables for matrix X? We can just solve this like an algebra equation, just about. We can say, we know, you know how in matrix equations we can't divide, but we can multiply by the inverse. So we'll multiply matrix A by the inverse of matrix A. So we'll say matrix A. If I take multiply this by the inverse of matrix A, inverse matrix A times matrix A times X equals, and let's see, keep this in mind. This is very, very important. Do not forget this, because if you forget this, you'll run into a lot of problems later. You'll run into a lot of solutions that are impossible. It equals, you want to put the matrix, the actual thing you're multiplying by, on the left side. You don't want to do inverse of A. You don't want to do B times the inverse of A. You want to do inverse of A times B. And you can see, because this is a 3 by 3 matrix, and this will be a 3 by 1 matrix. Otherwise, it wouldn't combine. And so all of our lives, and we've been multiplying, even in this lesson, when I've been multiplying both sides of the equation. So if I want to multiply both sides by like 2, I'd do 2 times this side, and this side times 2. Yeah, okay, sure, we can do that. But usually, but because we can't just swap A and B together and make it work, I have to always say what we're officially doing, what really is happening is doing 2 times B. That's really what's been happening this entire time. Every single time from algebra on up, when you've been multiplying both sides by an equation, you've always been starting on the left side. Officially in math, you've been multiplying you started the left side, you multiplied the left side 2 times everything, then 2 times everything. So 2 times this, 2 times that, not this times 2. It's not this. This is not what we've done. But then you would immediately use the commutative property of multiplication to switch it around. I hope I'm not confusing you. Anyway, the point is, keep this on the left. Multiply inverse of A times B, not B times inverse of A. So, okay. When you do this, these A's cancel out. So you get X, the matrix X equals the inverse of A times B. So if you could just find the inverse of A and multiply that by matrix B, you will find the answers. It'll give you the answers. That's a lot of heady stuff. Let's see if we can find an easy way to do that. Okay, and this is where things become beautiful. Now, I want you to know how to do row echelon form. I want you to know how to do reduced row echelon form. I want you to know how to do Gaussian elimination. These are important things. I've been wanting you to know how to do everything the previous lesson. And the reason why is because these are concepts that you need to know. They're important, and you've got to have them down. But once you have them down, once you kind of get the idea, there's really a shortcut to make it much faster. The shortcut is not helpful for you if you don't understand the concepts, and that's why I'm trying to get you to understand, do the actual work of the concepts. Once you get them down, you can use a calculator, and the calculator will solve just about everything for you. So let's get into the calculator and see how we can make this done almost lightning fast once we've gotten these ideas down and what we're doing, the actual algebra of what we're doing. Okay, so let's start with by introducing a new part of a calculator, or at least a part that you're probably not familiar with. If I look at the inverse of X button, that X, the negative first button, that inverse button, if you press second inverse, you will go into matrix mode, which allows you to enter matrices. So we start with the names of matrices if you just want to quickly put one into your calculator. But if you want to actually edit a matrix, we'll go over to the edit section. So let's go ahead and I'm going to go to edit. I'll choose matrix A. I'll make matrix A. The first thing it'll ask you is how many rows it is, and then how many columns it is. I want to go ahead and for the sake of this, I think I'll start with let's try putting in matrix A, the one we just made, a 3 by 3 matrix. So it's 3 rows, 3 columns. I'm going to plug it in. So just give me a second here. 2, -4, and 1. So you press the numbers and press enter, and you keep going, and you'll be good. -1, and then -1, -3, 2. Okay, and once those are in, you can just press second quit or second mode, and that'll get you out of that. Now you've got the matrix in there. It's in. So I'll go back. I'll edit B, and I'll make matrix B. I'll get, let's see, that's a 3 by 1 matrix. So it's a 10, 1, and 0. I'll quit out of that. It kind of automatically saves. Once you press the enter key, it's kind of one of those auto-save things. So we'll go out of that, then we'll go back, and our formula says if we multiply matrix A, the inverse of matrix A, by matrix B, we should get the answer. So I'll take the inverse of matrix A, I'll do a second matrix, and I will choose names. I'll go to names and I'll choose that A1, the 3 by 3, and then I'll just press the inverse button. The button we're pressing all this time, that gives us the matrix. X to the negative first, inverse of A, and then I'm going to multiply that a few times, and I'll go back to the matrix, second matrix, and I'll choose B. Inverse A times inverse of matrix A times matrix B, and I'll press enter. And it gives me 3, -1, 0. It gives me matrix X, what I'm looking for. So it gives me 3, -1, 0, which is X, Y, and Z. So just like we've seen before, X equals 3, Y equals -1, Z equals 0. This is incredibly powerful. Incredibly powerful. Now this won't work, of course, if there is no inverse to the matrix. Sometimes you get an A and there just legitimately is no inverse. You can still sort of solve it, I suppose, but there's no inverse to that A, and so you're kind of out of luck, and so if you get into one of those, you have to do one of the other methods to solve it. But if this is available, this is extremely powerful. If you can find the inverse, it's amazing, because just like from that poster from 7.2, you can, if you plug in a 50 by 50 matrix into your calculator and then plug in that constant side, you can do the inverse of A times B, and you will solve a 50 equation matrix system, 50 systems of equations, 50 equations with 50 variables each. You will solve a system of equations with like, I don't know, 50 times 50, just that many variables, with 2,500 variables in it. You solve that many variables at once. I'm giving the 50 point location and a 49 of 49 realms colliding into one point. Anyway, it's really powerful. It's really cool, and you now have an amazing tool. So if you wanted to solve, let me show you. If you want to solve this problem here, this problem right over here, you can now solve this problem. You just got to make a matrix that's big enough in your calculator. And this might actually be the limit. I think I tried to design it so that this actually goes to the limits of your calculator. So this is as far as your calculator can go, is something this big. But it can solve this. I think you can solve this, which is just, it's fantastic. It's phenomenal. This is how you solve a problem that's fast. And so most people look at this and be like, this is impossible. How do you even start this? And you could try to do Gaussian elimination for years, and that would work. Or if you know matrix math, and the inverse of A times B equals X, or the matrix X, you can plug this in faster than the time it takes for anyone to write it down, because you just got to put in the numbers, and then run the calculation, and you'll be done. You'll have the inverse. So you'll have all these variables solved. Anyway, really cool stuff. Really cool stuff. Stuff that I love. Maybe it's your stuff that you're like, oh, I just want to get this done. And that's understandable. Why not? I get it. But I hope you don't miss how cool this is and how powerful you now are. Okay. So your calculator can do other things too. Quickly, if I also put in the rest of the matrix, so let's say I made matrix C. I'm just going to put in a third one. No, that's entering matrix C. I want to clear that. I'm going to go back to matrix, edit, matrix C, and let's say I want to make a 3 by 4 matrix. A 3 by 4 matrix. And put in the full thing. 2, -4, 1, 10. Oops. Oh, okay. Let's clear that 1 and 10. And then we put in 1, 2, -1, 1, and then -1, -3. Oh, yeah. -1, 3, not 3, -3, -3, -3, 2, 0. Okay, so then if I take that matrix, we can actually we have a bunch of extra tools we have. We can go to matrix math, and then from here we've got a lot of tools at our disposal. We can use things like row echelon form, and that gives us a row echelon form. I can just do row echelon form of C, and it gives us, there it is, there's a matrix in row echelon form. That works just fine and dandy. If I want to find and again, row echelon forms matrices aren't unique. You can find a bunch of different row echelon forms for any matrix. And there's a bunch of different solutions. But what you really want to focus on is with the reduced row echelon forms. Now there's only one of those, because that's the answers. So matrix, if I go to reduce row echelon form, that's letter B, and I put in matrix C, reduce row echelon form, it'll just solve it for you. I think I plugged in the numbers incorrectly. That's probably what happened. I think I plugged in these numbers wrong, and that's why it gave something a little bit off. But this would give you the correct answers. I don't know. I'm not gonna waste your time trying to fix that. But just another reminder: make sure you put things in carefully and slowly. Okay. So calculator, super easy, painless way of doing things. But for these problems, when we actually get to the problems of the lesson, please make sure you do the method that it asks you to do. That's because I want to make sure you get the concept down as well as you can. Okay, so from here on, we'll just go ahead and work on the problems. Alright, let's tackle some problems. The first one, use substitution to solve the system of linear equations. Then check your solutions. Okay, m plus n minus 3p equals -13, 4n plus p equals -12, and p equals 4. Okay, so we're already in row echelon form in a sense, or we've eliminated enough to get there. Let's just use substitution to solve it. So we'll plug in 4 for p. So we'll get m plus n minus 3p equals -3p equals -13. We've got 4n plus, let's see, that's 4. That's actually, let's line this up. So 4n plus 4 equals -12, and then p equals 4. Okay, so if I subtract 4 from both sides, I get 4n equals, let's change this, make this all one color. Let's say that's going to be orange. So 4n equals -16, and then n equals -4. And so we've got n equals -4, p equals 4. We plug that into the last equation. So we've got m plus, let's see, n is -4, so n plus -4. And then -3 times, let's see, p is, let's see, we just find out that p is 4. 3 times 4 equals 13, or -13. So we'll get, let's see, m plus, let's see, -12 minus 4 is -16. So that gives us -16, excuse me, equals -13. And then we have, we should add 16 to both sides, so we get m equals 12, oh wait, no, 12, 16, yeah. Oh man, I did this problem wrong, didn't I? No, that's right, 3, yes. So our answer is 3, -4, and 4. That's our answer. Great. All right, problem 2, and here is where the mistakes start to flow. So I'm going to try to give you a tool to make this much easier, or to make it at least much less likely to cause mistakes. It says use Gaussian elimination to solve the linear system by finding an equivalence system in triangular form. So we're going to use Gaussian elimination. To start off with, I recommend taking this entire problem and carefully, very, very carefully, copying it to your right or copying it onto your paper, and then putting 2 lines between each problem. That way there's sufficient space you can work in between them and get stuff done, and then move on to the next side. Okay, so the first thing we want to do in Gaussian elimination is we want to get rid of that x in the bottom left corner. We're going to make that a 0x. We're going to eliminate it somehow. So to do that, we're going to match it up with the x above it, the 4x. So I can multiply the bottom equation by 4 to match it up with the 4x above it. I'll multiply both sides by 4. And here's what I can do. I'll use a little bit of special terminology. I eventually want to match it up with the equation above it. So I'm going to put it right above it. I'm going to put it right here. So we're going to put the equation. And what I'm going to do is I'm going to take that third row. I'm going to multiply by 4. So I'll do 4 times R3. And I'm writing this terminology. That way, in case I make a mistake somewhere, I will be able to know what I did, and I'll be able to backtrack so I can kind of figure out how to get back to where I was before. In fact, I'd recommend if you have 2 different colors, I'd recommend this would be a great place to use multiple colors. Maybe a color for each different equation, or just a color for the actual equations you're working with, and the equations that are more like work equations. I'm going to use a color just for the one that's just like extra work on the side, and then a color for the actual equations that I've generated. Okay, so this becomes 4 times R3 is 4x minus 4y plus 20z equals 168 is what that is. Okay, and now I put that in the beneath the row. So, and now I want to subtract the top row from the bottom row. So I'll be very careful. I want to make sure it's be a good idea to actually put down the subtraction signs, so your brain is very, very clear on what to do. Otherwise, it can get confusing. Hold on, let me make sure. Oh, look at that. I've already made a mistake. I've written down the problem wrong. I thought something was a little bit off. 4x minus 3y minus 4z equals negative 21. Oh, goodness. It's a good thing I caught that, because otherwise it would have been 30 and 2x. Let me check. 2x minus 4y plus 4z equals 30, and then x minus y plus 5z equals 42. Okay, good. Okay, so I'm gonna take that, and then I'm gonna say this is gonna go up here. So I'm gonna draw an arrow up here, because I want to make that no, I want to draw an arrow downwards because I want to make that the new bottom equation. Okay, that's going to be the new bottom equation. So it becomes 4x minus 4x equals 0x, or just 0. Negative 3 minus a negative 4y, negative 3y minus a negative 4y becomes a positive 1y. So I'll write a y, just plus y. And then negative 4z plus a negative 20z would be a negative 24z. And then finally, negative 21 minus 168 would be equal to negative 189, right? Yeah, negative 189. That seems right. Okay, good. I think that's all correct. I want to be very careful. I'm just going to double check myself real quick, make sure that I did this right. And that seems correct. Doesn't hurt to double check yourself, because it gets really easy to make mistakes. Okay, so we've got that one. Now we need to get rid of that 4x above it. Here's what I can do. I can take this. I want to take the 4x, and I'm going to do, let's say 4 times. Let's see. I want to get rid of this 4x here. To get rid of the 4x, I can divide that equation by 2, or I can multiply the top equation by 2. I think I'll multiply the top equation by 2 is what I'll do. So I'll do 2 times row 1 is what I'm going to do over here. And then, and in fact, I'll put that a space in between. I'll put that the space between row 2 so that I can do that operation properly. So we'll do 2 times row 1 is 4x, and then minus 8y, and then plus 8z equals 60. And now I'm going to subtract that from both sides. So that gives me, let's see, let's see, I'll take that results, whatever that result is, I'm going to put it right here in the middle. Okay, so that gives me, actually make that arrow smaller so things can line up better. So let's see, 4x minus 4x is 0. So that's because it's 0. And then negative 8y minus a negative 3y would be 8y plus 3y, which would be negative 5y. Yeah, 8, 7, 6, 5. Yeah, 5y. And then 8z minus a negative 4z would be plus 4z, so it would be plus 12z. 12z. Let's rewrite that. Plus 12z. And then that equals 60 minus a negative 21, which would be 81. Okay, so that's that. Now I'm going to go ahead and find a way to eliminate that y at the bottom, that bottom y. And the best way to do that is to work with the equation that's directly above it. Okay, we got 0, we got negative 5y, negative 12z equals 81. If I want to line them up as best I can, I can multiply the bottom by a 5. I can do that. It's going to make a really large number on the right, but we can make this work. Okay, so I'll multiply the bottom by 5. Actually, I'm going to move this entire thing over just a bit to the right, if I can. Just a bit over to the right, so that I can make a new operation. And we'll call this 4 times, 5 times y. So 5 times row 3. That'll give me, let's see, I can see 0, and then plus 5y, and then minus 120z, and then equals, just to be safe, because it's always going to be safe, we'll do 189 times 5, because there's just no room for error here, times 5. 189 times 5 is 945. 945. Negative 945. Don't want to forget that negative. Negative 945. All right, cool. Now, I'm going to add the negative 5y to the plus 5, to the 5y. I'll add these two together. You know, I guess I'll make the arrow where the plus sign is instead of in between. So that might be less confusing, I suppose. Yeah. Let's take that plus sign, and we're going to put that up in the second equation. Okay. So it gives us 0 plus 0 is 0. Negative 5y plus 5y is 0. And then negative 12z plus 12z plus a negative 120z, which should be 120 minus 12, should be 110, 108. I want negative 108z equals 81 minus 945. Let's just do this. So negative 120 plus 12. Just no room for error. I'm going to make this right the first time. Negative 108, and then negative 945 plus 81. That gives negative 864. Okay. Oh wait, no, I don't want to do that. I want to bring this down to the bottom equation. Negative 864. Yeah, I didn't want this up here. I want this down at the bottom. I thought I wanted it. Yeah, I want it down here. Okay. And that's the way I can bring this down. This can become. This goes down there. Okay. So great. So I've got zeros in the bottom, and then 1 0 in the next row, and then no zeros in the top row. I'm in row echelon form. Okay. So this. Let me just rewrite the rest of them. The furthest one to the right on each row is the one that's active, the one that's the real one that we're working with at the moment. But I'll rewrite both of them just to make sure that we are clear here. 2x minus 4y plus 4z equals 30. Let's see, it's the same row. Yeah. 2x minus 4y. We're doing the right row. Yeah. 2x minus 4y plus 4z equals 30. And then 4x. Let's see. 2x minus 4y plus 4z. Okay, cool. And then 4x minus 3y minus 4z. 4x minus 3y minus 4z equals negative 21. Okay, so, oh wait, no, that's not right. We're at 0. We're at 0. So it's got some built-in checks to help me make sure I'm not doing anything terrible. 0 minus 5y plus 12z equals 81. Okay, so those are the equations we're dealing with. And we can see we're in row echelon form, sort of. we can go ahead and solve for z here. So I'll do 108z equals 864. So I'm going to go ahead and solve that. Let me make sure that's what we're trying to do. Yeah, we're in triangular form. So we can just go ahead and solve for z. So let's see, negative 864. 864 divided by negative 108. That gives us 8. Clean number. That looks right. Good, good. So z equals 8. Great. So now I can just replace from here. I can well, actually let's write this in a different color down here. Let's make sure that that's clear. We can make that red just so we're very we know that's something that we want to keep track of. Okay, so z equals 8. I can replace the other two equations with the other two z's with 8s. So we get 2x minus 4y plus 4 times 8. 4 times 8 equals 30. And then we get negative 5y plus 12 times 8 equals 81. Okay, now we can solve for that. We can solve for y with the second equation. So 12 times 8 is 96. Oh, that's wow, it's been too long. 96. So 81 minus 96 equals negative 15. Negative 15 divided by negative 5 is 3. So y equals 3. Okay, so z equals 8, y equals 3. We can plug the y in now for negative 4, and we can get this becomes a 3. And so now we've got 2x minus 12 plus 32 is 30. So let's see, negative 12 plus 32 is 20. Subtract 20 from both sides, so we get 30 is 10. So this becomes 2x equals 10, or x equals 5. And that is our third answer. All right, so our final answer then is x equals 5, y equals 3, and z equals 8. Okay, so plug it in. X equals 5, y equals 3, and z equals 8. And that's our answer. Whew. You got to be careful with these, otherwise you can get into a lot of problems. Okay. And just because it's not a bad idea just to check our work to make sure that this is exactly true, that these are the answers. So we'll do 2 times 5 plus no, actually not plus, minus negative minus 4 times 3 plus 4 times 8. That gives us 30. And then 4 times, not the natural log, 4 times 5 plus, or minus 3 times 3 minus 4 times 8 is negative 21, which is what we need. And then 5 minus, let's see, 3 plus 5 times, let's see, z is 8, is 42. All right, cool. So those are the right answers. Those are the right numbers. We've got confirmation. We're in the right here. Not a bad idea just to confirm, even if you think it's right, to be 100% before you put the answer in, because otherwise you might run into trouble. Okay, perform the indicated row operation on the given augmented matrix. Okay, so we're going to take 1/3 row 1, and that's going to become row 1. That's what it's saying. We're taking 1/3. We take 1/3 times row 1, and that becomes the new row 1. So that's what we're doing. So we're doing 1/3 times 15. Let's see, it becomes 5, and then 12. But 12 times 1/3 is 4. And then 15 times 1/3 is 5, and then that becomes our new row 1. So that's row 1. Row 1 is that, equals now that, and then row 2 now equals 0, 6, 15. Okay, so 5, 4, 5, 0, 6, 15. Those are our new matrices. Okay. Then it says that's the answer. 5, 4, 5. Okay. Next one, use the specified row transformation to change the matrix. We're going to take 3 times row 1 and add that to row 2. So 3 times row 1 is, let's see, this is row 1, row 2, row 3. So 3 times row 1 equals 3, 24, 27. And we're going to add that to row 2. So plus row 2. If we're going to add that to row 2, we're going to add negative 3. So we're doing plus negative 3, plus 5, and plus a negative 1. So that gives us 0. We're doing pluses all the way through. And so that gives us 0, and then 29, and then 26. That's what we should have. So this would be 0, 29, 26. And that becomes, we add that to row 2, and now that becomes row 2, apparently. So 0, 29, 26, that's our answer. Okay. Number 5. What elementary row operations applied to the first matrix will yield the second matrix? Okay, so we've got to figure out what the difference is between the first matrix and the second matrix, and what we've got to do to the first matrix to get to the second matrix. Okay, so this first row, that looks exactly the same as the second row. Okay, the first rows look the same. The second rows, those look the same. Okay, so those are fine. The third rows, the third rows are different. Okay, what's different? Let's see. They've added 2. So they've added 2. Right? I guess you say this is, you subtracted 2 from this one. You subtracted 6 from this one. They subtracted, they subtracted 4 from this one, and subtracted 0 from this one. Okay. Oh, okay. So what they did, to get from this one, from this row 3 to that row 3, you subtract 2, then negative 6, then negative 4, then 0. How did they do that? How did they get a negative 2, negative 6, negative 4, 0? Well, it looks like they multiplied it by, they can multiply the top row. They can take the second row. So row 2 times a negative 2 equals negative 2, negative 6, negative 4, 0. Cool. So they took negative 2 times row 2, and they added that to row 3, and then that would give them the new answer. Yeah, I guess that would give them this bottom row here, and then that became row 3. I guess it's kind of implied. If you just add the last thing you declare in the equation, usually is what it becomes. So I don't need to add this extra becomes row 3, because we're just saying we're adding it to row 3. We're putting that into row 3. That's kind of what we're doing. So we'll say G is negative 2 times row 2, and they added to row 3, because I took negative 2, multiplied by the second row, added to the third row. That's all they had to do. Cool. All right, find a row echelon form for the matrix. What is a row echelon form for the matrix? Okay, so there's a lot of solutions again for this one. You could get there's more than one way you could answer this, and there's more than one possible answer. But we'll find one of them together, and to do that, we'll just do the operations from before. So do 1, 5, negative 4. Let's rewrite this over. 1, 5, negative 4. 1, 5, negative 4. And then we'll write 2 lines down. 4, 17, negative 4. And negative 2, negative 3, negative 12. Okay, so let's see. We want to get rid of that bottom one. Our goal is to make these zeros, and we start with the bottom left, or at least a standard way is to start with the bottom left. You could do it a bunch of different ways, but this is a surefire way to do it. So we'll start with the bottom left, and we'll try to line it up with the one above it. So 4 times negative 2 and 4 together. Let's see. I can multiply row 3. In essence, if you want to find the actual terminology, we'll multiply row 3 2 times row 3. That gives you this. It gives you negative 4, negative 6. Actually, let's make this a different color again. Okay, so 2 times row 3, got to be consistent, negative 4, negative 6, and negative 24. and then we're going to add that in to 4. Yeah, so add that into the next equation, to the one above it, and so essentially what we've got here, if you want to find the full equation, we're taking row 2. This is row 2 plus 2 times row 3, if you want to think about it that way, and that becomes row 3. But you don't have to worry about all that fancy terminology if you don't want to. This becomes 4 plus negative 4. Oops. This is all going to go down to the bottom row. 4 plus negative 4 is 0. Negative 17 plus negative 6 is 11. And yeah, that's 11. And then negative 4 plus negative 24 is negative 28. Okay. And then from here, we're going to go ahead and let's see if we can get rid of that 4 as well. So we'll do, let's see, row 1 times 4 will get us there. So we can do row 1 times 4. So that gives us, yeah, 4, 20, and is that right? Right down. That was a negative 4, so it becomes a negative 16. We add those together. We're going to add that to here, and we're going to bring that down to the second row. So that gives us, that'll give us, let's see, 4. Oh, we're going to subtract those. Never mind, we're going to subtract those. Ooh, I almost made a mistake there. Good thing I caught it. Subtract those. 4 minus 4 is 0. Let's see, 20 minus 17 is 3. And then negative 16 minus a negative 4 would be a negative 12. All right. And then finally, we get rid of that 11 at the bottom. We can get rid of that 11 by, oh, what can we do? It says, let's see, do we need integers? Oh, okay. So it's going to want integers in the end. That's a different thing. I'll work with it later. We need to find the common numbers between 3 and 11. So we need to multiply. Here's what we need to do. We need to multiply the 3. Oops. We need to multiply the 3 by by 11, and the 11 by 3. So we'll do 11 times row 2, and we'll do 3 times row 3. So 11 times row 2 is 0, 33, and then negative 132. Is that, let me just check to make sure in my head. Yeah, 120, 12, 132. Okay, I'm pretty confident about that. Okay, it doesn't hurt to be sure. 3 and then 33, and then negative 28 times 3 would become, let's see, it'd be 6, 80, negative 84, I believe. 60, 70, 84, yes. Okay, now we subtract both sides. Subtract, and that becomes, that's going to go down to the bottom row, because we want to get rid of that 11. We're trying to fix the bottom row. So that gives us, let's see, 0 minus 0 is 0. Negative 33 minus 33 is 0. Negative 132 minus a negative 84. Let's see, negative 132 plus 84 is 48. So negative 48. So negative 48. Okay, gives us negative 48. And then from here, yes, negative 48. And then from here we got 0, 3, 12. 0, 3, negative 12. And then finally, we've got 1, 5, negative 11. Or sorry, 1, 5, negative 4. Okay, cool. So now we're going to reduce this down a bit. We've got to get these to be equal to these to be 1s. So what we'll do is we'll multiply the middle row, row 2, by a 1/3 to get that down. So we'll do 1/3 row 2. That gives us 0, 0, 1, and negative 4. And then we'll do, I guess, yeah, we'll do negative 1/48 of row 3. So negative 1/48 times row 3, that equals 0, 0, 1, and then finally we have 1, 5, negative 4. And that, right here, is row echelon form. One diagonal ones, triangle zeros, good to go. And that's it. That's it. It's number 6. So you would plug this one into the answer. Okay, 7. Write the reduced row echelon form for the given matrix. Same problem, except it's bigger and we've got to reduce it down so there's zeros on the top and the bottom. Okay, so we've got 1, 0, 4, 1. I'll try to go through this one a little bit more quickly, but still carefully. So we got 1, 0, 4, 1, and then 1, 3, 1, 7, 1, 3, 1, 7, and then 1, 4, 0, 9. 1, 4, 0, 9. Okay, first order of business, same as always. We need to get rid of that 1 at the bottom. We can subtract row 2 from row. We can subtract row 3 from row 2. We can just they're already lined up. We can just do subtractions, and we can say we can bring that down to row 3, and we'll get 1 minus 1 is 0. Let's see, 3 minus 4 is negative 1. 1 minus 0 is 1, and 7 minus 9 is negative 2. Okay. Now, let's see, we need to get rid of the 1 above it. So we can just do another subtraction. Fortunately, it's all lined up again. Did I write that right? Yeah, I did. That's just really convenient. Subtraction. Thank you, math makers. We're writing an easy problem here, or an easier problem. This gives you, okay, subtraction, we get 1 minus 1 is 0. 0 minus 3 is negative 3, 4 minus 1 is 3, and then 1 minus 7 is negative 6. And you got 1, 0, 4, 1. There we go. And then, from here, let's see, we need to get that 1 all accounted for, the negative 1 accounted for. So we'll multiply row 1, or row 3 by 3. So it gives us 0, and then negative 3, and then 3, and then it equals, oops, I don't need to have an equal sign. Negative 6. Was that, am I doing this correctly? Yeah, 3, 3, 6, and negative 6. Cool. And then we're gonna subtract these from each other. So we'll do subtractions, and we'll bring that down to the bottom row. This goes down here. Okay, so 0 minus 0 is 0. Negative 3 minus negative 3 is 0. 3 minus 3 is 0. And 6 minus a negative 6 is 0. Interesting. Well, this is, you can, at this point, if you are running with this without doing reduced row echelon form, if you're trying to solve this, you could stop here and say, we've gotten a situation where 0 equals 0. The entire row is zeros. So if you were to put this back into equation form, you get 0z equals 0, or 0 equals 0. This is a 0 equals 0 problem, so in essence, we've got infinitely many solutions. This is one of those situations where we have infinite solutions. But for the sake of solving this problem, they don't care that we have infinite solutions. They want us to finish the problem. So we'll do that. Okay, we need to get the, now we've gotten that out of the way. I mean, it's done down at the bottom. We do need to get the second row so that the second line has a 1. This needs to become a 1, so we can full row echelon form, and then we can reduce the top and get the reduced row echelon form. So we will multiply. We'll multiply a negative 1/3 times row 2, and that'll give us, let's see, that'll give us 0. Let's see, that'll give us 1, and then negative 1, and then not negative 1. That'll give us 2. Okay. And then we got, let's see, we've got 1, 0, 1, 0, 4, 1. Now this is the answer. This literally is the answer that we have here. We have 1, 0, 4, 1, 0, 1, 1, negative 1, 2, 0, 0, 0, 0. We really can't go any further, even if we tried. But we've made a lot of progress. We've made this triangle here of zeros. We've tried to make, we've tried to make as many zeros as we can above for the reduced row echelon form right here. We've tried to make zeros, and we specifically by making this top zero here, we were able to make that zero, but that's all we could really do. We can't make any more zeros. We'd have to go further down. We'd have to get we'd have to get more variables solved in order to do more zeros. This is that 1 0 is as much as we can do. However, we just simply cannot make this a 1, this 0 1 like it's supposed to be. I mean, if you really want to get fancy, you could do really strange things, like you could add 1 to both sides of the equation of this, and you'd have 0 0 1 0. No, you can't even do that. No, you can't. So there's nothing we can do to make this a 1, and because of that, nothing reasonable, and because of that, we have to leave it as it is. This is as far as we can go in reduced row echelon form. It's kind of incomplete, but as far as it can go is as far as we have gone. And so that makes this the answer. This makes this right here the answer. Okay, for number 7. Now for number 8. It says, ooh, I'm in post right now, actually. I've already done these problems, but the audio didn't come in. Well, no, the video didn't come in, the audio came in fine. So let me just redo these problems real quick for you. They're really simple. Number 8 and 9. So number 8 says, write an augmented matrix for the following system of equations. It just gives you a system of equations, and you just gotta take the numbers and turn them, or take the coefficients and turn them into a matrix. Very, very simple. Let me tell you. This is the x, this is the y, this is the number, this is row 1, this is row 2. You just organize it just like a matrix. So you get 4, -2, 4, -8, 4, and 3. Ordered just like you see it. Just make sure that the x's are in line, which they usually are, and the y's are in line, which they usually are, and the coefficients are both on the right side of the equation, which they usually are. And so that just gives you the matrix here. So the augmented form of the matrix is that. 4, -2, 4, 8, -8, 4, 3. Let me make sure that yeah, cool. And then from here, we can go on to number 9. Number 9 says, write the system of equations that corresponds to the following augmented matrix. And for here, we're just doing the exact opposite. Again, really simple. All you have to know is the definitions, and you can just see the answers by looking at it. So this is row 1, this is row 2, this is x, this is y, this is the number. So we get 6x minus 2y equals 4, and then 6x plus 6y equals -4. We just copy that into the equation, and we get 6x minus 2y and 6x plus 6y. Great. All right, number 10. Solve the system of equations by finding a row echelon form for the augmented matrix. Here's what it's asking us to do. It wants us to make an augmented matrix, or just a matrix, and then solve it using row echelon form. The first step then is to find the actual matrix, to make the matrix. Now again, be very, very careful when you turn this into a matrix. It is very easy to mess up the entire problem just by copying down the problem wrong. And I've done it before. Don't make the reason why you're wrong just be, oh, I copied it down wrong. That'd be awful. Okay, so we've got, let's see, for the first row, we've got 1, -2, 1, 9. So we've got 1, -2, 1, 9. 1, -2, 1, 9. Then 3, -1, -2, 2. 3, -1, -2, 2. 3, -1, -2, 2. Okay, and then -4, 2, 3, 4. No, -4, 2, 3, -4. -4, 2, 3, -4. 4, 2, 3, -4. Okay, cool. This looks like the right answer, which is good. All right, now we just need to solve this using row echelon form, by making row echelon form. Here's what we can do. You can do what we've normally been doing. We want to start with that -4, but what we can do is we can, instead of trying to align the 3 and the 4, which means you have to multiply the top by 4 and the bottom by 3. What we can do is we can multiply the very, very top equation, row 1, by 4 as well. We can do 4 times row 1 and put that there. Actually, I'll put that right above it. 4 times row 1, and then we can add that in. So we'll get 4 times row 1 is 4, and then -8, 4, and 36. Okay? Then from here, we add them together. Yes, 4, -8, 4, 36. And we add them together. And we're going to put that answer down in the bottom row. So we'll put, let's see, 4 plus -4 is 0, -8 plus 2 is -6, 4 plus 3 is 7, 36 plus -4 is 32. Okay? Then we're going to go and get rid of that 3. Again, we can use the row 1. We can say row 1, or 3 times row 1 equals, let's see, 3, -6, 3, 27. And then they're all lined up now, so I can subtract 3 and 3, subtract all 4 of these. We'll put that answer down in row 2. Okay, so we got 3 minus 3 is 0. -6 minus a -1 is a -5. -5. 3 minus -2 is 5. And 27 minus 2 is 25. 27 minus 2 is 25. Okay, good. In problems like these, I just double and triple and quadruple check my work because it's so easy to make a mistake on something so simple, and you end up kicking yourself in the foot and wondering, how did I get that wrong? Kicking yourself in the foot, what does it even mean? Anyway, so we've done that. Now we need to get the -6. We're going to turn the -6 into a 0. We can do that by realizing that -2 in the first row can be. Oh, actually, no, we can't do that because we want to just deal with this -5 and -6. We can't deal with that first row because if I was to multiply the first row by, say, 3, then I would be adding 3x involved. We'd be adding 3 on the first column, and I don't want to add 3 in the first column because that'll undo this work right here. I worked really hard to get this 0 here. That'll turn that 0 into a 3. I don't want to turn the 0 into a 3. All that to say, it's good to just go. Sometimes it's good to just go by the system and say we're going to multiply -5 by 6 and -6 by 5. So we'll do that. So we'll do, let's see, -5 times row 2 and -6 times row 3. So -5 is, oh, no, let's switch it around. Oh, good thing I caught it again. Okay, -6 times row 2 and -5 times row 3. That gives us 0. That gives us, let's see, 0, 30, and then -30, and then 25 times a -6. That is, well, let's just do it. 25 times -6. That's -150. Just better than making a mistake. -150. I'd rather be stupid than make a mistake. People make mistakes. Never mind. So -5 times -6 is 30. 7 times -5 is -35. And then -5 times 32 is -160. Not 60, -160. There we go. 5 times 3 is 15. 2 times 5 is 10. Okay. So now we subtract these from each other. Subtract. I didn't have to multiply by -6 and -5. I could multiply by +6 and -5, or -6 and +5, or +6 and +5. But this is just the way I chose to go. So this goes down here into this row. Our answer. So 0 minus 0 is 0. 30 minus 30 is 0. -30 minus the -35, that'd be -30 plus 35 is 5. And we have -150 minus the -160, -150 plus 160 is 10. Okay. Oh, that looks like clean numbers. I like the way that looks. That suggests that I did things right. So 3, -1, -2, 2. I'm gonna, well, actually, no. I don't want to copy down the original. We've got this 0, -5, 5, 25. So we're almost in row echelon form using this. We've got everything lined up the way it needs to be. I'll just copy what we have so far over. So 0, -5, 5, 25. It's always a risk to copy things over because I could copy something over wrong. But I want to be clear so you can see what I'm doing. Okay. So now we've got everything lined up. We just need to make this diagonal here ones, and then we're in row echelon form. Okay, so let's see. -5 is we'll divide row 2 by -5. So we'll take row 2 divided by -5, and we'll take row 1, or is it row 3, and divide that by 5. So that gives us, on top we've got 1, -2, 1, 9. We've got, next row we've got 0, 1, -1, -5. Is that right? -5? Yes, yes. And then 0, 0, 1, 2. Great. Oh, this is looking good. This is looking good. I like the way this is. 1, -1, -5. Yes, yes. Okay, cool. Just triple checking here. So now we've got row echelon form. We can solve this pretty quickly just by making a quick reduced row echelon form. I can subtract. Let's see. I can make this. I can subtract. Or I can add row 1, row 2, row 3. I can just add those two real quick, and I can make that the second row. So that gives us 0, 1, 0, -3. And let's see, I can add that row times, I can add 2 times that row. I can have 2 times that row. And yeah, 2 times row 2. That is 0, 2, 0, -6. And I can add that to the original one, to the top one. The top one, and that gives us, let's see, if we add that together and bring it to the top, that gives us 0, 1, 0, and then 1, and then, let's see, 9 plus a -6 is 3. Am I doing that right? Yes. Yes, I am. Yes, I am. Okay, cool. Great. So 0, 1, 0, -3. And let's see, 0, 0, 1, 2. I can add the bottom equation to the top equation. I can subtract the bottom equation from the top equation. So we'll subtract from the bottom equation from the top equation, which gives us, let's see, and that, we'll take that, and we'll bring that, we'll bring it to the top. So that'll bring that up to here. I have no easy, clean way of subtracting rows that are not next to each other. This is the easiest way I can think of. So we do 1, 0, and then 0, and then 1. Great. So what we end up with, did I do this right? Just about. And yeah. So what I should end up with then is let's see, that'd be 1, 0, 0, 1, 0, 1, 0, -3, and 0, 0, 1, 2. So I get x equals 1, y equals -3, z equals 2. So 1, -3, 2 is the answer we're looking for. So 1, -3, 2. Did I write that right? 1, -3, 2. Yep. And that's our answer. Great. Okay, number 11. Let's hope we do this one right. Solve the system of equations by finding the reduced row echelon form of the augmented matrix. Same thing. We could have just done row echelon form and substituted things in, but reduced row echelon form worked very well in the previous one, so we do reduce row echelon form this one as well. So, or we're going to have to end up doing it, reduce row echelon form this one. Let's copy it down very, very carefully. So we've got 1, 1, -1, -6. Let's see, 1, 1. Let's keep it some space. 1, 1, -1, -6. And then, that's right, again, and then 4, -1, 1, 1. 4, -1, 1, 1. Did I get that right? Yes. And then 1, -3, 2, -2. 1, -3, 2, -2. And there it is. All right, that should be good to go. So now we just do the same process as before. I can subtract, just to do a little bit of shorthand here, I can subtract row 1. So I can subtract row 1 from row 3. So I can do subtract row 1 from row 3, and I can put that answer in row 3. So that goes down here. So 1 minus 1 is 0. 1 minus negative 3 is, so that's 1 plus 3, so that's 4. Let's see, negative 1 minus 2 is negative 3. And negative 6 plus 2 is negative 4. All right. So then we need to take, oh yeah, we need to get rid of that 4 in the middle. So what we can do to get rid of that 4 in the middle is we can do, let's see, 4 times row 1, or 4 times row 2. Row 1 or row 2 work fine. So let's do 4 times row 2. 4 times row 2. No, 4 times row 3, excuse me. Multiplying row 2 by 4 wouldn't make much sense here. We'll do 4, negative 12, 8, and negative 8. And then we will subtract. Okay, and we'll bring that up to row 2. So we'll get 4 minus 4 is 0. Negative 1 minus negative 12 is negative 1 plus 12. So that is 11, right? Yep. And then 1 minus 8 is negative 7. And then 1 minus 1 plus 8 is 9. Okay. And finally, we need to get rid of that, or not finally, but pretty close to finally, we need to get rid of that 4. We need to make that 4 a 0. And to do that, there's really no easy way to do it other than multiplying row 2 and row 3 by each other. So row 2 times 4, 2 times 4, and row 3 times 11. We need to do that to make those numbers match up. Equals 0, 44. Actually, this should be green. Okay, so 0, 44, and then negative 28 and 36. And then down here we've got 0, 44, and then negative 33 and negative 44. Then we add these, no, we subtract them from each other. 44 subtracts. Okay, so we've gotten, that gives us, we'll put that down below. Yeah, we want to put that down below. So that will give us, let's see, 44 minus 44 is, well, we get 0. 44 minus 44 is 0. 28 plus 33 should be 5. So that should be 5. And then 36 plus 44 should be 80. Okay. That looks comforting. I like those numbers. So that's good. And then that is row echelon form, just about, as long as once we get them all to be 1s. So we've gotten, if we divide row 2, well, if we divide, let's see, if we divide row 3 by 5, row 3 divided by 5, that is 0, 0, 1, and 80 divided by 5 should be 16. Let's just not make any mistakes, because sometimes my brain doesn't like me. Oh, that should be 5. Well, my brain likes me. My brain and I are bros. We just, sometimes I work him really hard. So, and he can't do everything. So that's okay. That's okay. Let's see. The 0, 11, negative 7, 5. We need to divide row 2 by 11. Divides by 11. And let's see. So we get 0, 1, negative 7 over 11. Aha. And I put an implied equal sign. And then 9 over 11. Oh no. What am I doing? 1, 1, negative 1, negative 6. That is already, it already has a 1 to begin with. So we're good there. Negative 1, negative 6. Alright. So now we're in row echelon form. We can make reduced row echelon form. And that's not going to be so fun right now because we've got 7 over 11 and 9 over 11. That's no good. But we can do it. So, well, that's what we'll have to do. So we'll find out soon if I made a mistake here. So let's see. We need to get rid of that 7 over 11. So we need to multiply row 3. So row 3 times. Let's make this. Yeah, we'll make this row 3 times times, let's see, that'd be negative 11 over 7. So this gives us 0. This is still green. This gives us 0, negative 11 over 7, and that gives us, let's see, that would give us 1, and then negative, and then that would give us, let's see, negative 9 over 7. Okay, interesting. No, hold on. This will give us, oh, oops, I'm not thinking properly here. I want to multiply the bottom by negative, I want to multiply row 3 by 7 over 11. See how easy it is to make a mistake? I should probably take a break after this. I don't know. We get 0, negative 7 over 11, and then, let's see, that'd be negative, 16 times 7 is 112. So negative 112 over 11. Okay, this looks really scary. It looks like we've done something wrong, but I'm going to trust the numbers. I think things are going to work out okay. We're going to subtract these two from each other. Subtract. So we get, and we'll put that in the middle row. So we'll get 0, 1, and then this becomes a 0, and then, let's see, negative, that's a 9 over 11 minus a 112 over 11. It's minus a negative 112 over 11, so 9 minus a negative 112 is 9 plus 112. Yeah, so we got 121 over 11. So this becomes 121 over 11, which looks scary, but 121 divided by 11 is 11. So this is 1, 0, and 11. Okay, that looks like a number that could actually be the answer, which is great. So let's see, we got 0, 1, 0, 11, and finally, we just need to finish up 1, 1, negative 1, negative 6. Okay, so I can subtract. Let's see. So let's rewrite this just to finish it up, so we're very, very clear and not worried about what's going to happen next. We've got 1, 1, negative 1, negative 6. So we're going to subtract the top and the. If we want to take care of that negative 1, this negative 1 here, I could subtract the top equation. I can add the top equation, row 1, row 3. I can add row 1, row 3. So add with row 3. And that gives us, we'll replace that with row 1. So that gives us, let's see, 1 plus 0 is 1. 1 plus 0 is 1. 1 plus negative 1 is 0. And negative 6 plus 16 is 10. Ooh, that's nice. That's nice. And then we can multiply row 2. We don't have to multiply row 2 by anything. We can just subtract row 1 from row 2. So we'll do, this is 0, 1, 0, 11. And then we subtract these from each other, and we'll put that in row 1. So we'll put the answer in row 1. Doesn't matter which row we put it in, but we decided to put it there. So 1, 0, yeah, 1, 0, 0, 1, 10 minus 11 is negative 1. So, and then 0, 1, 0, 11, and then 0, 0, 1, 16. 0, 0, 1, 16. Great. So our answers then are x equals negative 1, y equals 11, and z equals 16. So our answer then is, the answer we put in there is negative 1, 11, and 16. And that's our answer. Great. I'm relieved we did that one correctly. Alright, so this number 12 is solve the system of equations by finding the reduced row echelon form for the augmented matrix. Now, as you start getting into this, you don't want to make any mistake. This is going to be a hard problem. So we'll need to keep our wits about us and be very careful every step of the way. So the first thing we want to do is just what we've been doing for all of them. We want to make a augmented matrix. But the problem is, or just a matrix, but the problem here is that we're missing some variables. So let's go ahead and write down those extra variables so we know what we're missing. We have x plus y minus 3z, and you notice there's an extra w. There's a w variable, so we'll say this plus 0w equals 9. And then we have x plus 0y minus z minus w equals 3. Then we have 2x plus y minus 4z minus w equals 12. Okay. Okay, so we're going to solve this. Let's go. The first thing we're going to do is just make that matrix. So we've got a, let's see, we've got we got, for the first one, we've got a 1, 1, negative 3, 0, and 9. 3, yeah, negative 3, 0, 9. Then we have 1, and down below, we have 1, 0, negative 1, negative 1, and 3. So is that, yeah. Then we have 2, 1, negative 4, 2, 1, negative 4, and negative 1, and 12. Okay, so we've got all of this, and now what we need to do is we'll just do what we've been doing this entire time. You'll notice right off the bat that, this is a larger equation. This is a larger matrix than normal, at least widthwise, but lengthwise, but not widthwise. So we're going to come to some strange conclusions, it looks like, but you'll see what this means pretty soon. So we'll start by solving that bottom left one. So we can do this just in a normal way. We'll do let's see, r2 times 2 is, let's move that up. R2 times 2, that gives us 2, 0, negative 2, negative 2, and 6. We'll subtract those, and put that at the bottom. So that gives us 0, negative 1, negative, that'd be a 2. Negative 2 plus 4 is 2. And then negative 2 plus 1 is negative 1. 6 minus 12 is negative 6. Okay, then we need to get rid of that 1. So we can just subtract the top from the bottom, or the top equation from the middle one, row 1 from row 2. So we will do that, and then put that in the middle one, in the middle section. Let's change that arrow so it's cleaner. There we go. All right, so we've got 1 minus 1 is 0, then 1 minus 0 is 1, negative 3 plus 1 is negative 2, 0 minus a negative 1 is 0 plus 1, that's 1, yes, negative 3 plus 1 is negative 2, and 9 minus 3 is 6, 9 minus 3 is 6, great, and then the top one can stay the way it is. Now we need to get that we need to get the negative 1 to be a 0, so we'll do that. We'll subtract, and we will get, oh, here it's interesting. So we'll get 0 minus 0 is 0. 1 minus negative 1 is 1 plus, yeah, 1 plus 1 is 2. Oh wait, oops, so we need to add these. So I was trying to get rid of this. So it makes it 0. So we need to add these two. So there we go. That's better. Good thing I'm catching this now. So 0 plus 0 is 0. 1 plus a negative 1 is 0. Good. 0 plus, negative 2 plus 2 is 0. 1 plus negative 1 is 0. And 6 plus negative 6 is 0. Well, it looks like we got a bunch of zeros. So you might recognize what this means. This means that the answer is all real numbers. It's just all real numbers. That's the way it is. There's no other way to put it. It's all real numbers. But let's see. Let's just write in the rest of them so we can get the better picture. So 0, 1, negative 2, 1, 6, and then 1, 1, negative 3, 0, and 9. So we've got something that we can't solve. This is in the sense that there's infinitely many solutions. And so as far as if we were trying to solve for the variables x, y, z, and w, we'd say this is row 1 usually would help us solve x, row 2 would usually help us solve y, row 3 would give us z, and row 4 would give us w. Well, there is no row 4. Row 4, if you want to think about it, is all zeros as well. So row 3 and row 4 show us that z and w, or w, is all real numbers, and z is all real numbers. So that's a problem there. Well, so there's nothing we can do here as far as z and w goes. But we can try to reduce row 1 and row 2 a little bit more to see if we can try to make it just a little bit more in this reduced row echelon form. So we can't create we cannot create a giant box of zeros. But if you considered if you section this off just a bit, so just row 1 and row 2, you could say, you try to make that reduced row echelon form, you'd want this to be a 0, and you'd want, you have your rows of 1s, you have the rows of 1s, and you want this to be a 0. So let's make that row 1, column y, let's make that a 0 as well. So row 1, 2. If we can make that a 0, then maybe make it a little bit simpler, and then maybe we can call it quits after that, because there's no other solution. So let's do that. Let's subtract the top from the bottom, and then let's make that row 1. Let's make that row 1. So we'll get 1 minus 0 is 1, 1 minus 1 is 0, negative 3 plus 2 is negative 1, 0 minus 1 is negative 1, and then 9 minus 6 is 3. This is a more proper row echelon form-ish kind of answer. Still not much more we can do here, but that's slightly better. Let me make sure that I did this right. I added 2, I subtracted 1, and that looks about good. Yes. Cool. So this is, we have here, then we have 1, no, we have 0, 1, negative 2, 1, and 6. So we can't do any more with z and w. But if we want to try to solve this, let's see what it's asking for. Oh, yeah, so it looks like there's two options here. We can say there's one solution, there's infinitely many solutions, or there's no solution. So we know it's either B or C. And let's see, it says the solution is X, Y, Z, W, where, let's see, Z and, okay, so B says W, where W is a real number, and C says Z and W, where W and Z are real numbers. We've determined that W and Z are both unsolvable in a sense. They both give us those zeros. So we know it's C. We know that Z and W are our answers. Are the variables that have all real numbers. Z and W are all numbers. So what we need to do then is just figure out what to do with the first two. Let's see if we can make kind of equations for x and y. Let's bring this back into equation form to see if we can figure out if we can make an equation. This would be x. This would be x plus 0 minus z minus w equals 3 on the top, and we'd have 0 plus y minus 2z plus w equals 6. Okay, well, we can just get rid of these zeros first of all. Then we can solve, let's just go ahead and solve for x and solve for y, and that way we'll have an equation. So if we did know what z and w were, we could figure out what x and y are. But unfortunately, we don't know what z and w are. So we're kind of making equations in terms, like, an equation or an equation in terms of z and w. That's exactly what we're doing. Okay, so then we add z and w to both sides, so we get x equals, 3 plus z plus w, and then y equals 6 plus 2z plus, no, not plus w, minus w. Gotta be careful there. I'm subtracting w from both sides. Maybe it'd be helpful just to, if you want to make sure you're not making any mistakes, just to do plus z plus w plus 2z plus 2z minus w. Okay. That way you're careful here. Now, as far as with the answer, the format of the answer, they're probably going to want it in the first variable first, and then the constant last. What I mean is, like, probably want in the form like x equals z plus, can I get more space? No, I'm out of space. Plus w plus 3, and then y equals 2z minus w plus, no, here we go. Yeah, 2z minus w plus 6. There we go. Then we'll copy that, all of that. There we go. That's fine. I remember that's a 3. And then, ooh, that was a previous answer that was wrong from a previous take. So you gotta remember, make sure you be very careful in these. And then plus 3. Okay. And so our answer is not this mistake. That just happened just from the last step. Yeah, I made a mistake just on the very, very last step. And so shouldn't let your guard down. It's really too easy to make a mistake, even on the things you think you know well. But z plus w plus 3 for x, and then 2z minus w plus 6. And that is our answer. All right, 13. Write the system of equations as a matrix equation ax equals b, with a as the coefficient matrix of the system. Okay, this sounds really complex, but it's not. You're just translating into matrix form. So the a becomes the matrix of the coefficients, and then b just becomes the answers. So let's see. If we were to make a matrix, a would be the coefficients, so 2 and 9 and 1 and -4. This would be a. And b would just be the answers. The constants is probably the better thing to say. So we say, yeah, so we say a is 2, 9, 1, -4, and b is -3, 2, just like that. And that's all there is to it, fortunately. Okay, 14. Write the matrix equation as a system of equations. Simple enough process here as well. We're just doing the exact opposite. So if we're to multiply the matrix A times matrix X, we would get, if you just actually do that multiplication out, you would get 3x minus 3y, and then on the bottom you'd get 5x plus 4y. And then the answer is the same, -3 and 3. Well, so you would actually get this as one entry, and then as a 2x1 matrix, and then you get this as a 2x1 matrix. And so since it's the same 2x1 matrix, you could just say 3x minus 3y equals -3, and 5x plus 4y equals 3. Okay, this one shouldn't be. I hope this one's just a matter of definitions and language. Number 15. Solve the linear system of equations by computing x equals the inverse of a times b. Here's what you can do. We can calculate the inverse of a. Not too difficult here. I mean, if you remember the system of how to find an inverse matrix, we got. Let's actually make the a first. A is 1, 4, -2, 2. I don't want to get ahead of myself. Oops. And sometimes my device does things I don't really understand. 8 and 14 are our answers. So that's B. A. The inverse of A. So the inverse of A is let's see. That'd be, we know that an inverse, if it's A, B, C, D, that the inverse equals 1 over AD minus BC times, let's see, I believe that is D, -B, -C, and A. So that's the formula we're working with here. So just gonna go ahead and plug those numbers in. We get, let's see, here's what we get. This is 1 over, I got space for this. A times D would be 1 times 2, and then minus B times C, 4 times -2. And we're going to multiply that by, let's see, that'd be 2, 1, -4, and 2 is our values. So we get 1 over 2 plus, let's see, 8. And so 1 over 10. 1/10 times all of that, to negative 4 to 1, which gives us 1/5. Let's see, yeah, 1/5, and then this gives us negative 2/5, and then 1/5 and 1/10. That is our inverse matrix, assuming we haven't done something terribly wrong. And yeah, 1/5, negative 2/5, 1/5, and 1/10. That seems about right. So we'll go ahead and do that. 1/5, 1/5, negative 1/10. There we go. Okay, so now we have to multiply that by matrix B. Okay, if we multiply that by matrix B, we get this. Let's see, matrix B is 8, 14. So this times 8, 14 is, this will equal, let's see, this is a 2 by 2 times a 2 by 1, and so this is a 2 by 1 answer, as you're probably familiar, as you may be familiar with by now. And we know for row 1, column 1, we're going to multiply row 1 by column 1. So this gives us, let's do this, this gives us, let's see, 8 fifths plus, let's see, it'd be 28 over 5, or no, minus 28 over 5. And then for the top, and then for the bottom, we have 8 fifths plus 14 over 10. Okay, add those together, we get, let's see, 8 minus 28 is 20, negative 20 over 5, which gives us a negative 4 on the top. Negative 20 over 5 is negative 4, and then 8 over 5 plus 14 over 10 is the same thing as 16 over 10 plus 14 over 10, which is the same thing as saying 30 over 10, which is the same thing as saying 3. Okay, so negative 4 and 3 is our answer. The solution is negative 4, 3. And that's our answer. Great. Okay. Number 16. Solve the system using the inverse of the coefficient matrix. Okay. Select the correct choice below, and if necessary, from the answer boxes, click choice, simplify your answer, all that. So we need to solve the system using the inverse of the coefficient matrix. So we will just take the inverse here. We'll write the coefficient matrix 1, 5, 5, and then 1, 4, 5, 1, 5, 4. That's the coefficient matrix. And our answer matrix, or our constant matrix, is 23, negative 18, and negative 21. Our variable matrix is x, y, and z. So times, multiply as x, y, and z, that equals this. So a, x, and b. There we go. Okay, so I believe that's right. And if assuming that is right, which I think it is, we can just, at this point, we're finding the inverse of a 3 by 3. You can just use a calculator. So we'll just take out our calculators and go to second matrix. We'll make a 3 by 3. We'll do 1, let's put this in 1, 5, 5, and then 1, 4, 5, and then 1, 5, 4. Great. And for our B matrix, and then we'll go back to our matrix and we'll edit the B matrix. This is a 1 by 3, conveniently hard to put in. There's negative 23. Then we have a negative 18, and negative 21. Okay. So if we multiply, we'll get out of that. Now the rule is if we multiply a matrix A, go back to names in A, multiply the inverse of matrix A times matrix B, that should get us our answer. And there it does. Negative 12, negative 5, and negative 2. Okay, 12, negative 5, negative 2. 12, negative 5, and negative 2. And that is our answer. That's all there is to it. Okay. Number 17, solve the system of equations. You'll notice this is another one of those problems where it looks like there's an x, a y, and a z, but not all the variables are always represented, so we've got to be careful as we make this. This is actually x plus y plus 0z equals negative 10. We've got, that's a negative 10. Let's not make sure this doesn't look like a positive. Don't want to make a mistake on the outset. 0x plus y plus z equals negative 1, and then x plus 0y plus z equals negative 1. That's what we're dealing with here. And so we can solve this that way. Let's go ahead and do that. And I suppose since this could be an easy problem, easy-ish problem to solve without, we could use a bunch of different methods to solve this, I believe. But just for the sake of making this really easy on ourselves, let's just pull out the calculator again. Let's go back to matrix. We'll go back to matrix and we'll use edit. We'll go back to A and we'll do 1, 1, 0, no, 1, 1, 0. And we'll do 0, 1, 1, and then 1, 0, 1. And then we will quit, and then we will go inverse of A. We're going to multiply that by a B once we get the B. Make B is negative 10, negative 1, negative 1. Okay. So we'll quit out of that, and then we'll do matrix. We'll put in B. Inverse of A times B is negative 5, and 4. And that's our answer. So negative 5, and 4. Great. Now the next few problems, I've canceled out, so you shouldn't even see these next few problems. So I'm skipping to the last problem that we actually do have. It should be 18 for you. For me, it's not 8. It is, where is it? Here it is, 18. Let's see. Gonzalez Manufacturing borrowed $27,000. Part of the money was borrowed at 10%, part at 12%, and part at 14%. The total amount borrowed at 10% and 12% was twice the amount borrowed at 14%. Find the amount borrowed at each rate if the annual interest was $33,000. This can be, there's a lot of words in here, and it takes a while. I think it might take a little bit to understand even what it's talking about and where it's trying to lead you. You can probably tell, based on the nature of this lesson, that we're going to make some matrices and solve them, or at least make a system of equations and solve the system of equations. But how do we do that best? What are some equations we can make out of this? Well, we can see he borrowed $27,000. Part of the money was borrowed at 10%, part at 12%, part at 14%. I think the first thing that's easy enough for me to notice is it says the total amount borrowed at 10% and 12% was twice the amount borrowed at 14%. That seems like a classic math move that would make. So let's just give variables to these. Let's say the amount at 10% is x, the amount at 12% is y, and the amount at 14% is z. What it's saying is that the x and y, the total of x and y is 2 times the amount of z. So we would say that x plus y, the total of x and y, is 2 times z. So that's our first equation right there. That's a very helpful thing to notice first. Okay, then it says, let's see, what else can we find? He says he borrowed a total of $27,000. Well, okay, well, if he borrowed a total of $27,000, then we could say, let's see, x plus y plus z, all of them together, all the money borrowed would be $27,000. So that's good. We could say that all that together is $27,000. And then finally, let's see, what else can we have? That covers most of it. Find the amount borrowed at each rate if the annual interest was $33,000. Okay, this is where the actual percentage rates comes in. It says, let's see, the interest rate for that. Let's see, what is the interest rate? So interest is $33,000, or 3,300, not 33,000. That'd be more than the principal. Okay, 3,300, and let's see. The interest is the amount of let's see. The interest would be the amount of interest for x plus the amount of interest for y plus the amount of interest for z. But the amount of interest for x would be 10% times whatever they borrowed. So 10%, so 10.10 times x would be the amount of interest for x. Then we'd add that and say 0.12 times y would be the amount of interest for y. Let's make this 0.10 so it's kind of clear what these dots are. And then let's see, the 0.14 times z would be the amount of interest for z. And all those added together should then equal the total amount of interest, which is $33,000. Yeah, $33,300. Okay, so now we've got our three equations. We've got x plus y plus z equals 27,000, and we've got x plus y equals 2z, which is interesting, and we should move that over real quick. We should say that x plus y minus 2z equals 0. That's important, because that way we can keep all the variables lined up pretty simply. And then we could say, oh my community, 0.1x plus 0.12y plus 0.14z equals 3,300. Okay, now let's make a matrix and solve it. So let's see, we've got 1, 1, 1, $27,000. We've got 1, 1, -2 is 0, and then we've got 0.1, then 0.12, and 0.14 is 3,300. Okay, let's go ahead and just use a calculator and solve this that way, because that seems to be the speediest way. Matrix A is, we're going to say we're going to make that the first set. We'll say that's 1, 1, 1. Sorry, my iPad the storage got full. Gotta clear storage every now and then. It turns out, so if you plug these two equations in, that's enough of that. If you plug these two equations in, you get from matrix 1. Let's see, just to show you what I did. Matrix A is this. I plugged in the 3x3, and then for matrix B, I plugged in the answers, well, the constants, and then after that, if you go back and you plug in, if you go quit out and you choose inverse of A times B, inverse matrix A times matrix B, then you will get 6,000, 12,000, and 9,000. And so those are our answers. You just go over here, and those are our answers. And so that's it. So I hope you enjoyed this. I love this lesson. It's really hard. I understand it's really hard. But if you can do this, then I honestly believe if you've been able to make it this far, you've been able to do all this, even if you're able to struggle through it well enough, you are really able to do calculus. I think this stuff is tougher than most of the calculus that you go through. This class is really just designed to weed you through and see, can you handle it? And if you can make it through here, then you can handle anything. This is some intense stuff. But anyway, all that said, thanks. I know the last time next video will probably be the last video for me, and so I just wanted to thank you for all the time you've been able to spend with me. This has been a lot of fun, and I've really enjoyed being with you all, even though some of it's a definite struggle. We've done a lot of fun things in class together, and I've really had a good time. Thanks for letting me geek out in front of you for an entire year. I hope you get a chance, maybe just once or twice, occasionally, you could just geek out in front of someone else and say, "Yo, guess what I can do? I can figure out the one point in space where 50 dimensions collide that are 49 dimensional realms. I can figure out that one point in 50 dimensional space where they all collide, or something like that. You know, we're in the deepest part. It doesn't get deeper than this with pre-calculus. This is intense. But I'm really glad, and I'm really thankful you all stuck it through with me, and and we've been able to have this time together. I really enjoyed it. So thanks.